Hello everyone, my name is Founder Liu. I'm very sorry being not able to be in Las Vegas to present my work and hope this video will help everyone. So my talk is TensorLab, an autonomous deep learning system in the cloud. Original paper title is TensorDB. So some background of our work is we are the Data Science Institute at Imperial College, and we do a lot of data managing and infrastructure work to support the research of different departments. Our group is headed by Professor Ike Guo, and we currently carrying the eTricks project and for translational research, and also the optimized project for pharmacovigilance, and the smart heart project to analyze the cardiac MR. So today my talk is about the motivation under the TensorLab system, some details about the data stories, and also our APP framework. And at last, I conclude with some application and our future roadmap. So our motivation is to make a deep learning system could be available for all the research. We do some analysis. We found that the TensorFlow system is very hard to use for not a deep learning expert. And one of our PhD students from our group, Dong Hao, invented a tensor layer system, which become very popular. However, we do analysis of the deep learning research code, and the tensor layer reduces the code size like to 1/3 for building the network, but still there are lots of work in the data management part. This is especially true when we apply this deep learning to a large data set and in the production situation. So the challenge in many of the research is really first is the data management. In medical, we deal with multi-modality data, and for each image, we have multiple labels. And finding and managing the training data is become great challenge. The second is loading the data. Typically, we have to train a deep learning system with the training data is much larger than the hard drive or memory of computing. The third is we have to manage the versions of machine learning mode, model evaluation, mining, everything. This will become another challenge. And we also want to make everything autonomous as possible. So we hope we can build a system to streamline everything. And last is, in many cases, we have to monitor the training process like dozens or tens of mode, which become very challenging, and no existing system can handle this. And so our motivation is really put the data management of the training data and the machine learning together. So we build a big data warehouse, manage both. From the data perspective, so if you have the data, you have the mode, you can predict the label. And from the machine learning perspective, if you have the data and the label, you can also train your mode. So then this become a chicken egg problem. So you never know which go first, which go second. And everything become very chaotic for model builder, data analyzer, and the tensor lab solution is we build a searching engine like a data router. Then we can correctly schedule all the data paths. And then we build a bigger job queue that to schedule different jobs. And this job queue will distribute the data at different nodes. So the design principle behind the TensorLab is first, is everything is data, the model architecture, and the training log. Everything is stored in a data warehouse. The second design principle is everything is identified by database query language. All the APP or application via the query to talking to the data. The third is the data is designed in a pooling-based processing way. This enables our system to reduce the memory and hard drive cost, so it's only pulling the data when it is needed for training. And for the data storage scheme, we build a two-layer system. On the top layer, we use an index-based index system based on documentation database. So each documentation is a collection of a key value pair and store all the tags. On the second storage layer, we use something like a traditional file system. And when we query the data, we use a MapReduce searching engine to search the document database. On the APP framework, and in the backend, we have three databases, one for imaging and semantic labels, one for the machine learning model architecture, and one for the parameters and metric logs. And everything is connected to the application through a TensorDB data interface. On the software layer and the lower layer, we have something like a data ingester, data streamer, model logger, and data render. This is for low-level API. On the high level, we have something where like a scripting language can construct and distribute job in a high-level way. So on the API side, the left side is when we talking to the database using the TensorLab system by the low-level API. You see it's just a 10 lines code. Basically, it's connecting to the database, finding the training data, finding the parameter, and training the mode. On the right-hand side, you see that the high-level API. So basically, it's just like a dictionary. You give the name of the model architecture, the parameters, and the data, and tell how many training steps. And you can build something like a command line tool based on this. So it's very straightforward and easy to use. And our tablet application is one for our brain tumor segmentation. The challenge is we have a full imaging modality. We want to segment both the high-grade and low-grade brain tumors. And there are 4 types of tumors, and we want to do 5-fold cross-validation. So in total, we have trained something like 100 mode, but with almost the identical code. So with the TensorLab system, we can efficiently building like about 20 mode of deep learning mode, and then do the cross validation. And TensorLab really help us reduce the burden of management work. And another example is we want to make machine learning that become continuous. This have great application value because when your machine learning system is deployed, new training data will be added. And also, this is a typical application for the reinforcement learning. So in TensorLab system, we can have that data import interface. So new data keeps on importing, and the data streamer keeps on popping up the new data. So we can this can be implemented without changing one line of code. So currently, the TensorLab system is implemented based on MongoDB and running with a MongoDB cluster for the storage. And we have running tested with up to 32 GPU nodes for computing. And we are currently experimenting to porting the system to public cloud. And currently, experiment support for Google Cloud Platform is ready to use. The 1.0 ready release, we will support all the major cloud provider. And in the 0.20 version, we will support a hybrid and even cross-cloud support. This means that you can put a part of your data locally and partially of your data on the cloud, and maybe on different cloud providers. And thank you. So the alpha version is already released with the tensor layer system, and here is the link. I'm very sorry not being able to present this work at Las Vegas. And if you have any questions, please email me.